Yeah, others? All right. Okay. Osanda Vikramasinghe. Osanda, are you new today? Is today your first day? You can let me know in the chat box also, Osanda. Let me know if, yes. Yeah, tell me. Okay. All right. So let's start the class. Let me share the board. So increase the volume. Yes, 1 second. Is this okay? I increased the volume of my mic, so I hope you will hear me better. Because anyways, right, okay. Okay. So I have shared the whiteboard. Please stop drawing. I have shared the whiteboard, Lamai. I will send the link of the whiteboard in the main chat on Zoom. So you can click on it and see the whiteboard if you cannot see it. Okay. Okay. So since Osandi is also new today and for others as well, just a recap of what we have been doing. We finished the first lesson. We did the worksheet. We finished the second lesson, but we didn't do the worksheet yet. I will send the quiz, which I couldn't send yet. And then we were doing the third lesson, right? So last week, did I send you the whiteboard note? Did I send the whiteboard note in the group? Where did we stop last week? Can somebody tell me? Somebody quick.
First annexation energy.
Sorry, Jituli?
First annexation energy.
First annexation energy, and we wrote a little bit about it, and we talked about the variation of first ionization energy. Am I right? Okay.
We talked until, so we expressed the first ionization energy for 6.2022 into 10 number of atoms.
Okay, so is that the last thing we wrote? Is that the last thing we wrote? और
Yes.
मैं वहाँ पे zigzag के draw करें ना the graph.
No.
Which you said let's draw it this week.
Right. Okay. I told you that we'll do it today, no? Okay. All good. So today we have to finish the lesson. And I need your full support for that. Okay. So first ionization energy, the variation, we talked about it, but I said that we will draw it today. So Osanda, we are doing the third lesson. We started it, I think, not last week, the week before the last. And we are at first ionization energy. So as a textbook reference, we are at page 63. Okay. All right. So when we were talking about first ionization energy, right? We said that first ionization energy is how much energy we need to give to an atom which is at gaseous state. For an example, 1 second, in a question in gravitational acceleration, you find the height.
Excuse me, teacher.
Yes, Nikini.
Teacher, whiteboard එක open වෙන්නේ නැහැ.
Whiteboard deck open when 1 second, let me see. නිකිට මම දැන් link එකක් එවනවා ඒක බලන්න විනාඩියක් දෙන්න.
My teacher.
මේ link එක බලන්න. එතකන් the question is gravitational acceleration. Yes. Usually in a velocity time graph, we get displacement from the area under the graph. In a gravitational acceleration also, we get the displacement using the area under the graph. But gravitational acceleration can be vertical motion, right? Etakota displacement is the same as height. So yes, you are right. Apita gravitational acceleration graph එකකින් when you get the area under the graph, we are getting height. Yes. We are getting displacement, but displacement is height. So we are getting height. That's right. Nikini, can you see the board?
Yes, teacher.
All right. Okay, great. Okay, Lamai, it says that my connection is unstable. So I will keep my camera switched on for like 5 minutes. Okay. So last week, I told you, right? So when we have an atom, for an example, if you take sodium, when I have an atom, sodium in gaseous state, we know when we talk about materials, materials can be either solid, they can be liquid, or they can be gases, right? So you have to take an atom in the gaseous state. In the gaseous state, and I'm going to remove one electron from this. My electron remove because electron is a negative charge, right? So when I'm removing a negative charge, the atom take a negative it becomes positive. So now it's Na plus, and it should still be in the gaseous state. Shanaz, I will send the link of the whiteboard. You can click on it and wave. I sent it now. So මෙන්න මේ වැඩේට කොච්චර energy යනවද කියලා හොයලා, that is what we call the first ionization energy. Okay. Is that clear, Lamai? This is what we discussed last week. Okay. Okay. Others, right. Then where we stopped was we talked about the variation of first ionization energy. Okay, so look at this very carefully. I will take the second period. What is the first element of the second period, Lamai? What is the first element of the second period?
Beryllium.
Is it beryllium? Are you sure?
Helium.
Second period, first element. I just remembered. It's lithium. I just remembered. I asked you all to study the periodic table and come last week, neither. Who's confident that you have memorized the periodic table? I have completely memorized the periodic table. Give me a thumbs up. Okay, Chituli. Okay, Alia. Anyone else? Who's fully confident that you have memorized the periodic table apart from Alia and Chituli? Why is that we have 18 students and only 2 are confident? What about the rest of the 16? Okay, since majority of you okay, Senudi, did you get the recording of last week? Make sure you get the recording and watch it. Huh? Recording illala eka me balana anivaren. Okay. So since majority of you have not studied the periodic table this week, I will not be checking it. But next week I will be. Okay. So no excuses. Periodic table is something you must memorize. Kushit also has studied, ne? Okay, great, good. So only 3 of you have studied the periodic table. Mahada check karanna. Yes, Joshua. Anya has studied, okay? Okay. Can somebody, okay, so let's just do this, Ogalanta Pulwan. Out of all of you who have studied, can somebody unmute and tell me the order of the periodic table? Can one of you unmute and tell me the order of the periodic table?
Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium.
Yes, correct. Good, very good. So, Anita, next week I will be randomly calling out names. So, please study the periodic table and come. This is the last warning. I told you last week also. Okay. Let's move on with today's. Yes, Kushit.
H E
Okay.
E
H is hydrogen. Okay, then. Okay. Next week, then memorize and come. Everybody. Everybody. We will be checking it. Haridhar. Okay. So, let's start with the first ionization energy. Okay. Now, in our second period, the first element is lithium. Lithium ki first ionization energy, let's say, is this much. Then beryllium ki first ionization energy ga to ඊට වඩා ටිකක් වැඩි. Then, when you move to the third group, third element of a period, එයාගේ හැමලෙම චුට්ටක් අඩු වෙනවා. Then fourth එක්කෙනා ආයෙ වැඩි වෙනවා. Carbon. Fifth එක්කෙනා ආයෙ වැඩි වෙනවා. Nitrogen. Sixth එක්කෙනා ආයෙ චුට්ටක් අඩු වෙනවා. Oxygen. Seventh එක්කෙනා ආයෙ වැඩි වෙනවා. And eighth එක්කෙනා වැඩි වෙනවා. This is how first ionization energy varies in the second period. Okay, this is how first ionization energy varies in the second period. So we can see that lithium has the lowest first ionization energy and neon has the highest first ionization energy. Is this clear to all of you, Lamai? Okay.
Miss, can you explain again, please?
Yes. So if you take the one second. If you take the second period, may second period periodic table we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Lithium is the first one, beryllium is the second one. The first second ekata වැඩි වෙනවා. I third එකේනා චුට්ටක් අඩු වෙනවා. See, boron එකකට චුට්ටක් අඩු වෙලා. Then carbon, nitrogen again වැඩි වෙනවා. I sixth එකේනා which is oxygen I චුට්ටක් අඩු වෙනවා. Then fluorine, neon I වැඩි වෙනවා. හැම වෙලේම across the period from the first element to the eighth element, first ionization energy increases except for the third element and the sixth element. හැම වෙලේම දිගටම වැඩි වෙනවා. හැබැයි third එකේනයි sixth එකේනයි විතරක් චුට්ටක් අඩු වෙනවා. Everything else increases. Is that clear, sir, Shelly? Others, is it clear, Lamai? Okay. So, let's see what happens in the third period. Okay. Third period එකේ කවුද අපේ ඉන්න first element එක? What's the first element in the third period? First element in the third period. Yes. Sodium. Sodium. Then?
Sodium.
Yes. Then magnesium.
Magnesium.
Then aluminium. silicon, phosphorus, sulfur, chlorine, argon. But I hope you remember, right? Bala metana, ekka first ionization energy increase, but only the third one and the sixth one has shown a decrease. Everything else has increased, no? Anith okkoma වැඩි වෙනවා third එකනයි sixth එකනයි විතරක් චුට්ටක් අඩු වෙනවා. Is this clear? I hope this is also clear. Then if you take helium ගේ first ionization energy තියෙන්නේ මෙන්න මෙතන. Helium, hydrogen ගේ first ionization energy තියෙන්නේ මෙන්න මෙතන. So hydrogen and helium අතර මෙන්න මෙහෙම තමයි තියෙන්නේ. And then if you take potassium ගේ first ionization energy is somewhere here. Calcium ගේ first ionization energy is somewhere here. Now let's connect everything. Then periods හතර ටිකනේ මම මේ draw කරේ. Okay. So our first element is hydrogen, then helium, then lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then neon ගෙන් පස්සේ එන sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. And then we have potassium, calcium. This is our periodic table. Right? All the first 20 elements of our periodic table. So මෙන්න මෙහෙම තමයි first ionization energy vary වෙන්නේ. Okay, so if you look at the entire periodic table, when it comes to the first ionization energy, which element has the highest first ionization energy? Which element has the highest first ionization energy?
Helium.
Yes, and which one has the lowest first ionization energy?
Phosphorus.
No. That's not phosphorus.
Potassium.
That is potassium, yes. Phosphorus and potassium පටලවා ගන්න එපා. Potassium has the lowest first ionization energy and helium has the highest first ionization energy. Okay. Maker, you have to sketch it on your writing book, but don't take too much time and too much effort when you're sketching this. I just need a rough sketch. But හරියට values comparatively මෙයාට වඩා මෙයා වැඩි, මෙයාට වඩා මෙයා අඩුයි කියන එක සුට්ටක් බලලා draw කරන්න ඕනේ. ඊට කලින් I have one more thing to show you here. One second. I have one more thing to show here. If you look at one period, right, then first period එක ගන්න එපා. මොකද first period එකේ අපිට elements දෙකයිනේ තියෙන්නේ. Last fourth period එකේ elements දෙකයි. So don't take the first and the fourth period, but take the second period or the third period. If you take across a period from the first element to the eighth element, what has happened to the first ionization energy? Has it increased or decreased across a period? Period එකක first එකේ ඉඳන් eighth එකට වෙනකන් යද්දි. What do you all think? Has it increased or decreased? Let's just take the second period. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. It's second period के first element के lithium. Then beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So මෙන්න මෙහෙම යනකොට has the first ionization energy increased or decreased? Is what I'm asking.
Increased.
Increased. But has it increased throughout, or are there any exceptions? Are there points where it has decreased?
It also has
They have
decreased.
extension.
Yeah. Increased, but the third and the sixth one has decreased. Except for the third and the sixth elements, everything else has shown an increase. Then if you look at the third period also, the same thing. Overall, it has increased, but the third one and the sixth one has shown a decrease. Okay, that's all right. Then now I don't have a periodic table to show you. I'm not going to draw one here again. But you have the periodic table which we drew last week. So looking at the periodic table, what can you tell about the first ionization energy? If like consider one group. Now periodic table groups groups are the columns, right? So out of those 8 groups, consider one group. If you consider one group, as you move from up to down, what do you think has happened to the first ionization energy? ඔයා කැමති group එකක් අරගෙන බලන්න මේ group එකේ උඩ ඉඳන් පල්ලෙහාට යනකොට first ionization energy වැඩි වෙලාද අඩු වෙලාද? Okay, I got one answer. Others, what do you think?
අඩු වෙලාද?
Okay. අඩු වෙලා කියලා කියනවා සමහර අය. In the chat box also මට same answer that it has decreased, right? Okay, let's take in the periodic table, let's take the first group. Can somebody tell me what are the elements in the first group of the periodic table? මම periodic table එකට අග sketch කරන්නද? Hydrogen. හැමදාම මේක කරන්නේ නැහැ, but අපි තාම මූල දවස්නේ, so I will draw. Beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. What do you mean also this one? This graph you mean? If it's this graph, don't worry, I will give you some time. Once we are done learning this, I will give time because others also have not drawn this. Again, last week අපිට draw කරන්න වෙලාව තිබුණේ නැහැ. So මේක අද අපි draw කරමු අනිවාර්යෙන්. I will give you time after I explain this little part, okay? Okay. Neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. මම ඉරි ටික නම් අඳින්නේ නැහැ ළමයි. මට ඉරි අඳින්න වෙලාවක් නැහැ. But let's take one group. Groups can මෙහෙම තියෙනවනේ. So there are 8 groups here, right? These are groups. Then what are periods? As you very well know, periods are මෙහෙම තියෙනවා. There are 4 periods. So if you take one group, මම ගන්නම් මෙන්න මේ group එක. The first group, group 1. In this group, what are the elements we have? Hydrogen, lithium, sodium and potassium. බලමු what has happened to the first ionization energy. Hydrogen is here, lithium is here, sodium is here, potassium is here. Can you see any first ionization energy අඩු වෙලා කියලා? Group, if you consider one group, as you go down in the group, the first ionization energy has decreased. Okay, that is a good observation. That is something we are noticing now, no? අපි තව group එකක් බලමුද? Shall we check the fourth group? Fourth group එකේ තියෙන carbon and silicon. Let's see. Carbon is here, silicon is here. Again, we can see that it has decreased. Ne? Down a group from top to bottom, the first ionization energy has decreased. Then if you take the second group, beryllium, magnesium, calcium. Beryllium is here, magnesium is here, calcium is here. Again, it has decreased. If you consider the 8th group, helium, neon, argon. Helium here, neon here, argon here. Again, it has decreased. So when you move from top to bottom in a group, the first ionization energy has decreased. But when you move from left to right in a period, the first ionization energy increases except for the 3rd and 6th elements. Up to that point, is it clear, Laman? Up to that point, is it clear for everybody? Please give me a thumbs up if it's clear. If you have questions, you can ask in the chat box. Or you can even unmute. Hari. එහෙනම් මේක sketch කරගන්න ළමයි. Quickly sketch this. Again, as I said, ගොඩාක් මහන්සි වෙලා ලස්සනට rulers rule එකක් තිබ්බට කමක් නැහැ. But don't take too much time is all I'm saying. Okay? Once you're done sketching with this, I will write a few sentences at the bottom. Please copy them down also. Now you all can draw. My graphic. ළමයි a little something as you're drawing මේ මම අන්තිමට චුටි sentence එකක් ලියලා තියෙනවා මේ sentence එක උගාන්ට දැනට තේරෙන්නේ නැති වෙයි but just write it once you're done writing I will explain that sentence okay මේක sketch කරලා මේ ටික ලියාගන්න I will give you 5 minutes 6 minutes quickly Others, you have around 3 minutes. Quickly finish. Huh? Done, Namai? All right. So I'm going to explain this last sentence a little. When you move from top to bottom in a group, the first ionization energy decreases. A particle already, right? This is because the attraction to the electrons in the outermost energy level from the nucleus decreases. What does that mean? Let's compare lithium, sodium, and potassium. So, compare. If you want to hydrogen, compare. Hydrogen gattu themelamai. What is the atomic number of hydrogen? What is the atomic number of hydrogen? Hello, quickly tell me. What is the atomic number of hydrogen?
H.
Hydrogen?
1.
Atomic number of hydrogen is 1, yes. That means there is only one proton. Then how many electrons of how many electrons does hydrogen have?
1.
1. Electronic in the that one electron is like this. Okay. Then if you take lithium. Lithium, how many electrons are there?
3.
3 electrons. Why? Because the atomic number of lithium is 3. That means lithium has 3 protons. That means it has 3 electrons. Then what is the electronic configuration of lithium?
3.
Electronic configuration?
2, 1.
2,
3.
1. Kushit, 3 is the number of electrons, right? Number of electrons or energy levels will arrange karahama. Electronic configuration is 2, 1. Okay. So, lithium, we have 2 electrons and we have 1 electron. Rama, can you please excuse me for 1 minute? Please excuse me for 1 minute. Huh? Okay, I'm sorry, Lamai. So lithium is 2, 1, right? Okay, then sodium. What is the atomic number of sodium? What is, sorry, atomic number, can you tell me the electronic configuration state of it? What is the electronic configuration of sodium?
Teacher, you are lagging, teacher.
1 second.
281.
Okay, 281. Can you hear me now? Am I still lagging?
No, okay, teacher.
Now okay, no? Okay. All right. I don't know why that happened, but let's see. If I'm lagging again, let me know. So sodium will atomic number 11, 8 and 11 electrons. That means the electronic configuration is 281. So sodium in the mevage. First energy level ke electrons dekakino. Second energy level ke electrons atakino. 1, 2, 3, 4, 5, 6, 7, 8. I will teach you how to draw this later, right? There's another lesson coming in the future. In that lesson, I will teach you how to draw this. For now, just look at the board and listen to this only. The last energy level, okay, there is only 1 electron. You know, in first ionization energy, we are removing only 1 electron. Ban hydrogen will 3 electron. මේ electron එක remove කරන්න අපිට හරිම අමාරුයි. Why? Because if you, you know, at the middle of the atom, there's a nucleus. Nucleus is holding the electron. A nucleus is positively charged. Nucleus has protons and neutrons. Neutrons don't have a charge. Protons are positively charged. The nucleus is positively charged. Electrons are negatively charged. So positive and negative are always attracted, right? The nucleus is electron එක හයියෙන් අල්ලගෙන ඉන්නේ. ඒතර electron එක ගලවන්න නම් ඔයා ගොඩක් ලොකු energy එකක් දෙන්න ඕනේ. ඒ කියන්නේ hydrogen වල first ionization energy එක වැඩි. lithium බලන්න. lithium ගේ මම මේ එළියම තියෙන electron එකනේ ගලවන්නේ. මෙයාව ගලවද්දී nucleus එකට කියලා චුට්ටක් ඈතින් ඉන්නේ. nucleus එකට පොඩ්ඩක් ඈත්, nucleus is at the middle now. nucleus එකට චුට්ටක් ඈතින් තමයි මේ electron එක ඉන්නේ. So it's a little easier for us to remove that electron. ඒ කියන්නේ යාට යන first ionization energy එක hydrogen වලට වඩා අඩුයි. Then if you take sodium, sodium ගේ මේ එළියම තියෙන එකනනේ අපි ගලවන්නේ. එයා nucleus එකට වඩා තවත් ඈතින් ඉන්නේ. It's much farther from the nucleus. ඒතර එයාව ගලවන්න මට එච්චර ගොඩක් hydrogen වගේ අමාරු වෙන්නේ නැහැ. For that I can give even a lesser amount of energy. That is why first ionization energy decreases as you go down a group. Group එකක උඩින් පල්ලෙහාට එද්දී energy levels ගන්න වැඩි වෙනවනේ. Because atom becomes bigger, right? එතකොට nucleus එකෙන් අර එළියෙම තියෙන electrons වලට තියෙන attention එක අඩුයි. ඒකෙන් අපිට ටග් ගාලා ගලවන්න ලේසි. හැබැයි ළඟින් ඉන්නකොට attention එක වැඩි හින්දා අපිට it's difficult for us to remove that electron, so we have to give a lot of energy. Then the first ionization energy increases. Is that clear to you, Lamai? Give me a thumbs up, please. Make up a draw කරන්නේ නැහැ. මොකද අපි ඉස්සරහට we are going to talk about this in much more detail. But that is about first ionization energy. Can you all put a subtopic electronegativity? Electronegativity. Is Shana's in the class? No. Okay. Now let's see what electronegativity is. Okay. So now for now, don't write anything, don't draw anything, and just listen to me, right? So when two atoms are in a bond, you have heard about compounds, no? Compounds can atoms elements sometimes elements don't always stay alone, right? There are certain elements that stay alone, but most of the time elements don't stay alone, they stay together with other elements, right? For an example, let's take hydrogen and fluorine. Hydrogen and fluorine, they stay together sometimes. How do they stay together? They form a bond. Bond bond. We call this a bond. Shanaz, I think it's a connection issue from your end. Can others see? Can others hear me?
Yes, teacher.
Shanaz, it must be a connection issue. Can you move to a place with better signal? Then it might be okay. Because volume and others can hear. So must be some connection issue. Okay. So as I was saying, hydrogen and fluorine, they sometimes stay together. When they stay together, they form a bond. For an example, let's say you see a couple in the roadside. So the couples they are holding hands. Okay, so something like that. Or sometimes let's say there's a father and there's a daughter. තොර ගොඩක් වෙලාවට කොහමද මේ තාත්තගේ දුව කියලා අඳුනගන්නේ ගොඩක් වෙලාවට තාත්තා දුවව අතින් අල්ලගෙන ඉන්නේ. right? ශනාස් ඇත්තට මම නෙවෙයි absent present mark කරන්නේ මම නෙවෙයි ඔෆිස් එකේ මිස් තමයි මාක් කරන්නේ. එතකොට මම ඒක චුට්ටක් ක්ලැරිෆයි කරන්නම් attendance mark කරන විදි කීපයක් තියෙනවා. එකක් තමයි ඕගොල්ලන් 2.5 hours කියන්නේ සමහර 7:15 වෙනවනේ ගොඩ දවසට පටන් ගද්දි. So during that entire class if you are present you will be marked as present. So for the entire class if you are present for the entire class you will be marked as present. But now let's say 2.5 hours in a class එකේ or let's say like 2 hours විතරක් වගේ let's say 2 hours or 1.5 hours වගේ නම් ඉන්නේ ඔයාව mark කරන්නේ partially present කියලා. right? If you are like if you don't join the class ඔයාව absent කියලා mark කරන්නේ. ශනාස් ඔයා මට WhatsApp එකේ ඔය concern එක දාන්න මම චුට්ටක් ඒක check කරලා බලන්නම්. Because I remember last week also you said something like that or I saw somewhere on WhatsApp maybe. මට WhatsApp එකේ දාන්නකෝ එකකටත් I will check with the miss in the office. So ඕගොල්ලන් ගොඩක් වෙලාවට hope එකේ text කරන්නේ office එකේ Mr. her name is Miss Divya. So she is the one who's coordinating with you, messaging with you, talking to you and most of the time group එකේ messages දාන්නේ Miss Divya තමයි. certain whiteboard notes share කරනවා තමයි මම දාන්නේ. ඒකින්ද මට attendance ගැන ලොකු idea එකක් නැහැ but I will check with her just put your concern on WhatsApp. Okay? දැන් එතකොට hydrogen and fluorine එකට ඉන්නේ. එකට ඉන්නකොට they are forming a bond. Right? When they are together like that we say they are in a bond. So this is a bond. Right? මේකට අපි කියනවා bond එකක් කියලා. bond එකක් හැදෙන්නේ ළමයි hydrogen gives one electron and fluorine gives another electron. hydrogen ගේ ඉන්නේ electron එකකුයි fluorine ගේ ඉන්නේ electron එකකුයි එකතු වෙලා තමයි bond එකක් හැදෙන්නේ. A bond is formed using one electron from hydrogen atom and one electron from fluorine atom. ඒතර ඒ electrons දෙක එකතු වෙලා තමයි bond එකක් හැදෙන්නේ normally. Right? එතකොට when hydrogen and fluorine are in a bond like this, now there are two electrons now. ඒගොල්ලන් අපි කියනවා now this electron belongs to hydrogen. This electron belongs to fluorine. But when they are in the bond, we say they are sharing the electrons. When they are in a bond, they are sharing the electrons. What does that mean? That means earlier this electron belonged to hydrogen. Right? But now that it's in a bond, this electron belongs to both hydrogen and both fluorine. Okay? Then if you take this electron, initially this electron belonged to fluorine. But now that it's in the bond, now this electron belongs to both hydrogen and fluorine. Okay? So මේ දෙන තනි තනියෙන් හිටියා නම් මේ electron එක hydrogen ගේ මේ electron එක fluorine ගේ දෙපැත්තට. But now that they are sharing the electrons and they are staying in a bond, these two electrons belong to both hydrogen and fluorine. Up to that point, is it clear? About
Miss, can you
bonds?
explain it again?
Sorry?
Can you explain it again?
Yes, I will explain it. Yes. So most of the time, sometimes elements are alone. But sometimes elements are forming bonds and staying together. Bonds කියලා කියන්නේ ඒගොල්ලෝ එකතු වෙලා ඉන්නවා. Right? කොහොමද ඒගොල්ලන් එකතු වෙන්නේ? They share electrons when they are forming a bond. Initially, let's see how they are sharing these electrons. Initially, මේ electron එක hydrogen. මේ electron එක fluorine. Before the bond, before they are forming the bond, this electron belongs to hydrogen and this electron belongs to fluorine. But once they form the bond, they share the electrons. Yes, you can only share electrons. මේ electrons දෙක දෙන්න share කරගන්න. So මේ electrons දෙක hydrogen ටත් අයිති, fluorine ටත් අයිති. Because they're sharing the electrons. Is that clear, lamai? Give me a thumbs up. Others? Okay. So that is how it usually happens. They share electrons. But now there's a small problem. What is that problem? When hydrogen and fluorine are like this, now they're sharing electrons now. All elements have a property called electronegativity. Electronegativity කියලා property එකක් තියෙනවා. Hydrogen ගේ electronegativity එක අඩුයි. Hydrogen has a low electronegativity. I will explain what electronegativity in a bit. Fluorine has a high electronegativity. Because of that, what happens is that now when these electrons are being shared, the electrons then මැද ඉන්න පැය ගන්නට. හැබැයි ඇත්තටම ඉන්නකොට මේ electrons දෙන්න ඉන්නේ fluorine ට ගොඩාක් මෙහෙම ලං වෙලා. Okay? So actually when the two electrons are being shared, they are being shared between the two. So the electrons should stay balanced නේ at the middle. හැබැයි ඇත්තටම ඉන්නකොට ඉන්නේ මේ electrons දෙන්න fluorine ට ලං වෙලා ඉන්නේ. Still, the two electrons belong to both hydrogen and fluorine, but they stay closer to hydrogen. Sorry, they stay closer to fluorine. The two electrons belong to hydrogen and fluorine both, but they stay closer to fluorine because fluorine has a higher electronegativity. එහෙනම් මොකක්ද electronegativity කියන්නේ? When two elements are in a bond, if one element can attract the electrons in a bond more towards itself, අපි කියනවා එයාගේ electronegativity එක වැඩි කියලා. මම ඒක සිංහලෙන්ුත් කියන්නම්. Elements දෙකක් bond එකක ඉන්නකොට electrons share කරලානේ ඉන්නේ. එක element එකකට පුළුවන් නම් ඒ bond එකේ ඉන්න electrons දෙන්න එයාගේ ළඟට වැඩිපුර ලං කරගන්න. ඒ කියන්නේ එයාගේ electronegativity වැඩි. So in this case, fluorine was able to attract the electrons in the bond more towards itself. Therefore, fluorine has a higher electronegativity than hydrogen. Still, the two electrons belong to both. Electrons, they're not a maite. If you take before you reach 18, you belong to both your mother and your father. Before you reach the age of 18, you belong to your parents. But sometimes you may be closer to one parent. Right? For an example, that child belongs to both her father and mother. But she's closer to her mother. ඒ වගේ තමයි electronegativity. The electrons belong to both hydrogen and fluorine, but they stay closer to fluorine because fluorine has a higher electronegativity. Is that clear to you, Lama? Give me a thumbs up. Others? Okay. Then shall we start writing? You put the topic electronegativity now. So let's start writing. Mark Mariana, then we can save time. Okay. ළමයි, a little something here. අපේ periodic table එකේ වැඩිම electronegativity තියෙන fluorine ගේ, අඩුම තියෙන potassium ගේ. If you take noble gases, helium, neon, argon ගත්තාම ඒගොල්ලන්ට electronegativity නැහැ. කියලා තමයි අපි consider කරන්නේ. Because noble gases are so stable, they're very stable. Therefore, they don't form bonds. ඒගොල්ලෝ අනිත් පැත්ත එක්ක bonds හදන්නේ නැහැ. ඒගොල්ලෝ තනියම තමයි ඉන්නේ. Bonds හදන්න නැත්නම් electronegativity ගැන අපිට කතා කරන්න බෑනේ. Because electronegativity is how an element attracts electrons in a bond towards itself when it is in a bond, right? But if the element is not in a bond, we can't talk about electronegativity. Therefore, noble gases well, we don't talk about electronegativity. Give me 1 second. My board එක චුට්ටක් මෙහාට move කරා පොඩ්ඩක් ඉන්න. I just want to move this periodic table, that's right. Okay. Now the board is here. You can continue writing.
Do we have to draw that diagram?
Yes, draw the diagram. මම හිතන්නේ ඒක ඔයගොල්ලෝ ලේසියෙන් පාඩම් කරද්දී so that you have something visually. Underneath, I'm going to try to draw a little sketch of a periodic table.
Miss, can you scroll it down?
Like this. Can you see now?
Yeah, Miss.
No.
Do we have to write the periodic table again?
Yes, Ashali, we have to draw the periodic table. මොකද මේ variations අහනවා exam එකේ.
Okay.
Okay. Make it fast, ළමයි, yeah? For this entire thing, I will give you like 5 minutes because all this time you were writing too. 5 minutes would be enough. Quickly write. Done, Lamai? Everybody? Give me a thumbs up quickly. Because we have to move on to the next part. So, now going to
No,
pay
teacher.
are you done now? Do you need more time, Nikini?
Need more time.
Okay. 2 minutes. I'll give you 2 extra minutes. Quickly finish. Okay, Lamai, done? Nikini, done? Thumbs up, please. Thumbs up if you have finished, everybody.
Yes, teacher.
Okay, great.
Okay, teacher.
Okay. So, now we are going to be talking a bit about our metals, non-metals, and metalloids. Can you all tell me what are the metalloids in our periodic table? Because if you remember week before the last or something, we shaded, like we used different colors to show metals, then non-metals, metalloids, noble gases, and all that. So can you tell me some metalloids in our periodic table?
Boron and silicon.
Boron, silicon.
Okay, do others also think the same? Any other answers? Same. Yes. In our periodic table, boron and silicon are metalloids. Metalloids means they have properties that are between metals and non-metals. They got metals or properties with non-metals or properties with So, mamme udanda in a periodic table ke shade karanang, but we are not going to draw it again, na? Don't worry, mukada peda draw karapinda I make an no. So we said boron and silicon are metalloids. And we said whatever is to the left side of metalloids are metals, except for hydrogen. Hydrogen arena metalloids were at the left side again hamoma. We call them metals. So in our periodic table, in our small periodic table, lithium, beryllium, sodium, magnesium, aluminium, potassium, calcium, they're all metals. Then whatever is to the right side of the metalloids, whatever is to the right side of metalloids and the hydrogen, මේ metalloids වල right side එකේ ඉන්න හැමෝමයි hydrogen ඔක්කොම we said they're non-metals. Right? We said they're non-metals. So hydrogen, helium, carbon, nitrogen, oxygen, fluorine, neon, potassium, not potassium, phosphorus, sodium, chlorine, argon, they are all non-metals. Then we also said helium, neon, and argon are also metalloids. Metalloids are noble gases. So if you are given a periodic table, can you identify which ones are metals, which ones are non-metals, which ones are metalloids, and which ones are noble gases? Can you identify? Give me a thumbs up. If you think you can identify, give me a thumbs up. Anita, better. Others can't. Periodic table like do not metals, non-metals, metalloids, noble gases identify kara.
Miss,
Yes, Jitule.
can we write helium, neon, argon for both metalloid and noble gases?
For noble gases and non-metals. Helium, neon, argon are non-metals. They belong to the non-metals category, but also they are noble gases. They are non-metals mein thamai. Non-metals, but ඒ තුනට විතරක් special නමක් තියෙන noble gases. But they're still non-metals. Okay, Chituli?
Okay. Miss.
Okay. Now we are going to be talking about metals and non-metals in more details, right? Make up your shade karanna hai, so we will just write. Make a karanakota, we will first write and then explain. Okay. So I would prefer if you write with me so that we can save time. So put a subtopic like a main topic, metals. Mulima topic yadaganna metals. Non excuse me. Metals, non-metals, and metals. Okay. Excuse me, Namai. So put the topic metals, non-metals, and metalloids. And then under that, put a subtopic metals. And you can write with me. Apil, you want to pass explain karumo? I think that would be easier. Okay, Lamai, quickly
Miss, will
write.
you scroll it down?
Yes, Jituli, what is it?
No, Miss, no.
Okay. Quickly write this, Lamai. මෙතනින් පස්සේ ඉතුරු ගොඩක් ඒවා අපිට තියෙන්නේ I will do it in question and answer format, so we won't have a lot of writing, but I wanted to start by writing a little bit. Once you're done writing this, I will explain. Can you all hear me now? Maria, is it okay now? Okay, just write this quickly and then we'll discuss. Okay. Others done? Anybody who needs more time? Okay. 1 more minute. Quickly finish. 1 more minute. Huh? Okay, Lamai. So metals. In our periodic table, do you all remember in the big periodic table? I'm not going to show it to you now again because when we were discussing that, we talked about it. But on your textbook, can you go to page 65? Everybody quickly go to page 65. Excuse me. On page 65, you can see the bigger periodic table. That is the modern periodic table. What we are learning is only the first 20 of that. Can you see most of that periodic table is shaded in blue? And blue shows all the metals. Therefore, in the big periodic in our small periodic table, metals in it should type, right? In the small periodic table, only this much is metals. But if you take the bigger periodic table, most of them are metals because most of it is colored in blue. In our periodic table, most of the elements are metals. Metals exist in different ways in the nature as native metals. සමහර metals ළමයි nature එකේ ඒ metal එකේ විදිහටම ඉන්නවා. For an example, if you take gold, gold is a metal. In the nature also gold ඉන්නේ gold විදිහටම තමයි. ඔයා gold ගත්තොත් එතන තියෙන gold. Silver, platinum වගේම ඒ විදිහටම ඉන්නවා nature එකේ. But some are metals. For an example, sodium ගත්තොත් you can never find sodium as sodium. ගොඩක් අය අනිත් තාත්තක combine වෙලා ඉන්නේ. එක්ක sodium with oxygen, sodium oxide හදා නැත්නම් sodium with chlorine, sodium with nitrogen, sodium with sulfate. එහෙම එක එක අතක combine වෙලා තමයි sodium ඉන්නේ. එයා කවදාවත් තනියෙන් ඉන්නේ නැහැ. So they exist as compounds. Sodium, potassium, calcium, lithium, they all exist as compounds. But if you take silver, gold, platinum, those usually exist as native metals. Native metals කියන්නේ ඒගොල්ලෝ කාත් එක්කත් combine වෙලා නෙවෙයි ඉන්නේ. තනියම ඉන්නේ. Then what are the physical properties of metals? Metallic luster. Almost all the metals have a certain shine to them. So if you see, have you all seen iron? Iron rust වුණාම නම් shine එක පේන්නේ නැහැ when like මේ මොනවාද මලකඩ කෑවම පේන්නේ නැහැ shine එක. But if you take like clean proper iron, it shines. If you take the sodium metal, it shines. Let me show you like some pictures of metals. Some of these metals you may also have seen. This is a piece of magnesium. Can't you? Others, can you all hear me, Lamai? Savina, maybe there's a connection issue. Can you reconnect again and see? Like, log back into the Zoom same link, you'll be able to hear, I think. Or maybe some other connection issue in the Veneti, you can move to like a different place and check. Okay, so this is a piece of magnesium. You can see how much it shines, right? Then if I show you a piece of sodium, this is a piece, this is some sodium. Again, you can see sodium, again, sodium also is a metal, so that also shines. If you take lithium, this is how lithium looks like. It also has a certain shine. It's not like that glittery shine, but it has a certain shine, right? If you take calcium metal. So this is how the calcium metal looks like. See, again, it has a certain shine. So almost all the metals have that metallic luster. If you take like gold, we know gold anyways shines, right? So this is gold. Then if you take platinum.
Teacher, you are lagging.
Why is that? Give me a second. Can you all hear me now? Can you all hear me now? Others? Okay. So as I was saying, so this is silver. This is gold. This is platinum. This is magnesium. This is sodium. This is lithium, calcium. So almost all the metals have a metallic luster. That means it shines. The sonorous means metal heකට ගැව්වම පොඩි නිකන් එනවා echo වෙන sound එකක්. So you take a piece of iron and you like hit it with something, you hear that like not like a very big echo, but you hear a certain like echoey sound. So most of the metals give that certain sound that is called sonorous. Then most of the metals, if you take, one second. So most of the metals, they exist in the solid state at room temperature. ගොඩක් high room temperature එකේ if you take sodium, potassium, magnesium, calcium, lithium, all of them are solids at room temperature. එකම එක්කෙනයි metals වල liquid එකක් ඉන්නේ room temperature එකේ, that is mercury. Mercury is the only metal that is a liquid at room temperature. Everything else are solids at room temperature. Malleable කියලා කියන්නේ ළමයි, you take a piece of iron, යකඩ කෑල්ලක් අරගන්න, and then you like hit it with a hammer. What will happen to it? එයාව තැලෙනව නේද? ඔයා hammer එකකින් ගැහුවම එයාව තැලෙනවා. So you take like a piece of it can bend also, yes. You take a piece of iron and you hit it with a hammer. ඔයා මෙයාව තලන්න මෙයා flat වෙනවානේ. So මොම වාට ඕන නම් මෙයාව මෙහෙම sheet එකක් වෙනකම්ම flat කරන්න පුළුවන්. But if you take like glass එක කැල්ලක් අරගෙන මම hammer එකකින් තලුවොත් මොකද වෙන්නේ? කුඩු වෙනවා. Metals හැම කුඩු වෙන්නේ නැහැ. Right? So metals are not broken into pieces when you hammer it. Instead, metals will get hammered until it becomes a thin sheet. Thin sheet එකක් වෙනකම්ම එයාව hammer කරන්න පුළුවන්. Then that is called malleable. Ductile කියලා කියන්නේ ළමයි metals use කරලා wires හදන්න පුළුවන්. So ගොඩක් වෙලාවට අපේ මේ ගෙදර circuits වල හැම තියෙන copper wires, and copper is a metal. Then there are magnesium wires, there are zinc wires, even there are iron wires, right? So most of the wires, actually all the wires that we use in our day-to-day life, they are made of metals. So metals can be used to make wires. That's why we call them ductile. Non-metals වලින් අපිට එහෙම කරන්න බෑ. Sulfur කැලක් අරගෙන ඔයාට එකේ wire එකක් හදන්න බෑ. Okay? Then also they are good conductors of heat and electricity. They conduct heat well and they also conduct electricity well. And generally, metals also have a high density. Chemical properties namma liquid explain karanna damma mukada in the future we are going to be talking about this in much more detail. They form positive ions or cations by losing electrons. Yes. Up to the physical properties, is it clear, Lamai?
Miss, you were lagging earlier.
Am I still lagging? Am I?
No.
Up to which point did you hear?
Physical properties that good conductors of heat.
Right. Okay. So they are good conductors of heat and electricity means it conducts heat well. Piece of yakada kalak again rat koroti me hundar rat kar. And it can also conduct electricity well. All the metals. High density means all the metals have a very good density. They are quite heavy. Metals are generally quite heavy. Okay. So those are all the physical properties of metals. Up to that point, is it clear to all of you, Lamai? Give me a thumbs up, please. Okay. Chemical properties, Ganna, we are not going to be talking much details here. Because in the future, we are going to be doing 2 lessons. Ekak thamai chemical bonds, which I suppose is the 9th lesson. 8th or 9th lesson. And 9th lesson actually. Chemical bonds is the 9th lesson. And then we are also going to be doing another lesson called changes in matter. මේ grade 10 වලම. ඒ lessons දෙකේ තමයි අපි මේ points ගොඩක් discuss කරන්නේ. But just to get an idea, මම චුට්ටක් කියන්නම්. All the metals always like to remove electrons. සාමාන්‍ය metals වල property එකක් තමයි ඒගොල්ලන් කැමති electrons අයින් කරන්න. Right? So ඒගොල්ලන් electrons අයින් කරාම ඒගොල්ලන්ගේ negative ගතිය අයින් වෙනවනේ. So they become positive. Right? So that's why we call them positive ions. Positive ions වලට කියන තව නමක් තමයි cations කියලා කියන්නේ. Also, all the metals, they combine with oxygen and they form oxides. Most of the metals are sodium, maybe potassium, maybe lithium, beryllium, magnesium, aluminium, calcium. Megala okkam oxygen එක react කළා හදන oxides. Those oxides, we call them basic oxides. They have a property called basic. Right? ඒවා වතුරේ දියුණාම basic solutions හදනවලු. Right? Again, you don't know the meaning of the word basic. We will talk about it later. But for the moment, I'm still lagging. I'm lagging again, no? No. It showed that my connection is unstable. Man, chuttakata camera off karanna lamai. I think that would be better. For a little bit, I will switch off my camera. So those are the chemical properties. Chemical properties, Ganna, don't worry about it too much. As I said, we will be discussing them in the future. As long as you got like a very rough idea, that is more than enough. So then on the metals, Namai, we are going to be talking about a few examples. Api metals wala examples dekha kata karna. One is sodium. Put a subtopic number 1 කියලා. Sodium. This is a metal. Sodium. ඒකත් තමයි අපි මුලින්ම චුට්ටක් ලියලිමු දෙටක් ගාලා. Let's quickly write that also. It's better if you could write with me so that we can move fast. මාතකම ලියන්න. sodium වල මෙතන it's better to put in bracket Na. That's a symbol of sodium, right? මේක මම ලිව්වට පස්සේ explain කරන්නම්. So quickly first write. ළමයි ඔයගොල්ලන් don't worry about what's on the textbook and what we are writing because textbook එකේ තියෙන ඔක්කොම ඔයගොල්ලන්ගේ exam එකේ අහන්නේ නැහැ because some of the things are a little too complicated for you now because as I said there are so many things that you don't yet know. ඒකයි මම සමහර ඔයගොල්ලන්ට කිව්වේ we will be talking about them in the future but for now just write කියලා මොකද සමහරව explain කරන්න බෑ ඔයගොල්ලන්ට without teaching you the bigger picture. ඒකින්ද මම ගොඩක් මේ ටික simple විදිහට තමයි ලියන්නේ ඔයගොල්ලන්ට පාඩම් කරන්න ලේසි වෙන්න because in chemistry in the future chemistry lessons we will be talking about this again. So don't worry about it and just study it very simply. Okay? Actually, I'm not talking now. Just, excuse me. Just, I just asked you to write this for now. Okay? Maybe then I will quickly explain sodium. I will give you 4 minutes to finish writing this. Just 4 minutes. Quickly write. If you have any questions, do ask. Okay. Did you all finish writing now, Mai? Others? Okay. Come on, Antim keep writing. I will explain meanwhile. So sodium is generally very reactive. Like a marm reactive danga lame wage. Shanaz, you can keep writing. I will slowly explain. Huh? So sodium is very
Yes,
reactive.
in school we did.
What is it, Joshua? At school?
In school we did a test to see in water.
Yeah, I'm going to show you a video of that. So it's good that you did it at school because, of course, in the online class, we don't have the laboratory facilities. And I think some of your schools, other schools also, you may have done that test where you put a piece of sodium into water and it just zzz, and it moves all around water. Evo cooking videos all right? So that's a very good point. Okay. Others where you all did that experiment or that little activity at school? Okay, anyways. So sodium reacts. Can you all hear me? Right, okay. I'm sorry, my connection is not very good today. I don't know why, but I suppose it's because it's a little windy outside. So I just initially I tried to switch to hotspot, but I don't think that'll also work because my mobile data is also not very strong. Okay. So I'm sorry for that. I hope it's not very bad. But yeah, anyways. So let's continue what we were talking about. Yes, sodium is very reactive. Reactive क्या ना दाकिन दाकिन हम लोग तक react करना. Oxygen रखो तगल oxygen का react करना. I mean in the atmosphere, if sodium is oxygen gas, तगल oxygen का react करना. Nitrogen gas का रखो तो यार तक react करना. Hydrogen gas का रखो तो यार तक react करना. Then water देखो तो water तक react करना. Acids देखो तो यार तक react करना. It reacts with anything and everything almost. So it's very reactive. Ekin খাওয়া দাওয়া তো out of nature ke you cannot find sodium as the pure sodium. Pure sodium on nature ke hoga na ba. Because sodium is so reactive, it reacts with everything and it makes compounds. That's why you can never find pure sodium. Right? The main compound of sodium is something called sodium chloride. Sodium chloride will chemical formula is something called NaCl. Now, at home, we use salt, no, right? We use salt to flavor our food, right? Ape kya mada lunu dana wane. Lunu ko in the where do we get salt from? Where do we get salt from?
Ocean.
From the ocean, from the seawater, right? So that salt is actually sodium chloride. Ape day-to-day basis ekaka, mone ethnicity kunad, mone race kunad, mone country kunad, people in general use salt a lot to flavor food, to preserve food, to enhance certain like flavors, certain properties, whatnot, right? So itakuta salt is mainly sodium chloride, and sodium chloride is found in seawater. So sodium in the main compound is sodium chloride. So I told you sodium is very reactive. No, sodium marm reactive. Yeah, nikam hem sodium kala kele tibbo. Yeah, oxygen ekare react karna. Kaat ekare react karna. Ekinda I can never like keep sodium in the lab just on a rack. Right? Mata lab ke nikal rack ke sodium store karne ba. Aye. Yeah, itne oxygen ko bhi kara. Chalo wadak nahi. If I want to store sodium, what I have to do is I have to put it in paraffin oil. Paraffin oil ke oil jaate hai na. නැත්නම් kerosene. Kerosene is භූමිතෙල්. ඒවල දාලා තමයි ස්ටෝර් කරන්නේ. එතකොට අර එයා එක්ක තියෙන contact එක නැති වෙනවනේ. Otherwise එයා දකින් දකින් හැමෝත් එක්කම react කරනවා. Okay? So, I will show you a few videos. Um, Okay, I will screen share, I guess. 1 second. Can you all see my screen? Can all of you see my screen, Lamai? Okay. I hope others also can see. So this is cutting sodium with a knife. Okay, let's see.
Yeah, what? Yeah, what?
That looks a bit like AI. I don't know. Let's see this one. See? You can cut the metal with a knife, right? Sodium carry now. There are like small pieces of sodium. But generally, if you take a piece of iron, can you cut it with a knife, Lamai? If you take like a piece of iron, can you cut it with a knife? Can you? Can you all hear me now? Can you all hear me now? Okay. So if you take a piece of iron, you cannot cut it with a knife. It's impossible. But sodium is generally softer, so you can cut it with a knife. This is another video. Since my connection is not very strong, metin paraffin oil, Lamaya. Metin paraffin oil. So here the piece of sodium is stored in paraffin oil. Okay, so look at this. See, paraffin oil wala thiyena ekak thamai ganne. The sodium looks a little discolored here, but don't worry about it. Samara paraffin wala godak kala tiyeddi එහෙම වෙනවා. පෙන්නනවද cut? Yes. See? So easy to cut. It's very soft. See? It's very soft. Actually silver color එක පේනවා. It has the luster. But ආගේ luster එක ටක් ගාලා නැති වෙනවා. Okay? Yellow color වෙලා තියෙන්නේ because it's stored in the paraffin oil. Also, I will show you another video. ළමයා videos එක පෙන්නනකම් camera එක off කරලා තියන්නම්. I think the connection is not very strong. Okay. Let me find that video here. This one.
If you got 1 to 4 correct, you're a chaotic think.
So මේක තමයි මේ වීඩියෝ එක තමයි අතන මම මගේ ළමයි ඔක්කොරම පෙන්නන්නේ ක්ලාස් එකේ. One second. So මමගේ sound එක අයින් කරලා තියෙන්නේ so that I can talk. So this is the paraffin oil. Right? හැමෝටම screen එක පේනවද කියලා මට එකපාරක් කියනවද? You can just give me a thumbs up. Okay, great. So this is paraffin oil. Paraffin oil නැත්නම් මේක kerosene වල දාන්නත් පුළුවන්. I told you because sodium is very reactive. If you keep it outside, it will react with something, some compound. Oxygen. Hari කාත කරේ react කරන එකකින් අපි ආවේ paraffin oil වල store කරලා තියෙනවා. This is paraffin oil. This is paraffin oil. So let's see what happens.
Like the lithium, the sodium is stored in a mineral oil to minimize reaction with the oxygen in the air.
So we're taking that out.
If we remove a piece of sodium metal, we note that it's also coated over with an oxide coating.
See?
Group 1 metals become
You
softer as
can cut
you
it
go down the column.
with a knife, right? If you take like, as I said, other metals, most of the metals are very hard. So it's not easy to cut with a knife. Sodium we can. See, you have the metallic luster, right? It shines.
Goes over very rapidly with a layer of oxygen. Sodium is
Uh,
metal.
so මේකෙන් අපි කරන්නේ මෙයා electricity conduct කරනවාද කියලා බලනවා. මේකේ මේ light එක පත්තු වෙනවා කියන්නේ it conducts electricity. So see what happens when you put sodium into water, right? Because I told you sodium is very reactive, no? So see what happens when you put it into water.
And add it to water. We notice a much more rapid reaction with the water. Like lithium, the sodium is less dense than water and floats. The metal moves across the surface.
Normal නම අනිත් metals මෙහෙම water වලට දැම්ම කියලා ඔච්චර you cannot see like a reaction like that. But in sodium you can see it because it reacts like very violently or very vigorously with water. Water එක මාර fast react කරනවා. That's why you can see it so clearly. Okay?
Being pushed by the hydrogen gas that
And you
is
can see
produced.
like it's moving
As you
around
go down
so
the column
fast.
with group 1 metals, the melting point
And
of the
actually you can also hear a sound like swaggy sound එකකුත් එනවා. Joshua, did you hear that sound and did you see this when you did this in the lab at school? Did you see it like this and did you hear this sound? Like a sound?
Yes, yes.
Yeah. So that's because sodium is very highly reactive. Let me share the whiteboard again. තව එකක තියෙනවා ළමයි shorts අර මේ YouTube එකේ මම තව videos ටිකක් හොයලා ඔයගලන්ට එවන්නම්. I mean technically I don't even have to send because it's all over the place. ඔයගලන් නිකන් search කරලා බැලුවොත් එimhe ගොඩාක් හම්බ වෙනවා මේ වගේ videos. දැනුත් මම ඔයගලන්ට YouTube එකේ තමයි search කරේ. Okay, we're back to the whiteboard. I have a question. Sodium reacts violently with water, but the place you can find sodium is in the water. In the water, we cannot find sodium as sodium. Sea water වල sodium ඉන්නේ sodium විදියට නෙවෙයි. එයා ඉන්නේ sodium chloride කියලා compound එකක් විදියට. Okay, in water you can find sodium as sodium chloride as a compound. So ඒතර අර pure sodium නෑ. But pure sodium when you put it into water, it reacts violently like that. Is that clear, Maria? Okay. So yeah. Physical properties, yes, soft metal can be cut with a knife. It has a low density. Low density in the වතුර float වෙනවා. Conductor of heat and electricity. So actually, almost all the metals have a high density, but sodium වලට විතරක් චුට්ටක් low density එකක් තියෙනවා. Chemical properties, it reacts rapidly with oxygen, reacts vigorously can very fast react කරන water එක්ක. It also reacts violently with acids. There are so many acids in the lab. ඒගොල්ලෝ එක්කත් react කරනවා sodium. Then lamai, you have to write the uses of sodium alone. Can you go to page 67 on your textbook? Go to page 67 on the textbook. At the bottom, you have the uses of sodium. One of the uses එකක් තමයි production of sodium cyanide used in the extraction of gold and silver. So ළමයි ගොඩක් වෙලාවට gold and silver අපි ගන්න mines වලින්. Mines තියෙන පොළවේ. Right? පොළව හාරලා you mine the soil and you get sodium and gold and silver. So the gold and silver extract in a process එකේ we need something called sodium cyanide. That sodium cyanide we get from the sodium metal. That is one of the uses. Ek homework විදිහට ලියන්න. Then making sodium amalgam, which is used as a reducing agent in organic chemistry. Reducing agent කතාව ඕනේ නැහැ. Just there is something called sodium amalgam. Sodium amalgam කියන්නේ ළමයි sodium is mixed with mercury and sodium amalgam කියලා එකක් හදනවා. Organic chemistry කියන්නේ in chemistry is a huge subject, right? Chemistry වල there's a branch called organic chemistry. Right? There are certain specialists in organic chemistry. A organic chemistry වල අපි use කරනවා එක solution එකක්, it's called sodium amalgam. ඒකටත් sodium use කරලා තමයි හදන්නේ. Then extraction of metals like titanium and zirconium from their compounds. there are like titanium, zirconium are metals. They are very important. They are very valuable. They are also found in the ground, like inside the earth. So when you extract titanium, zirconium, and metals like that, you need sodium in that process. A process එකේ sodium ඕනි වෙනවා. Production of indigo dye used to dye trouser materials. You know, most of these ගොඩක්ම denim materials තියෙන blue color නේ. ඒ blue color එක ගන්න indigo dye එකකින්. ඒ dye එක චුට්ටක් දැම්මහම you get the light color, light blue denim. If you put the indigo dye a little more, you get a dark colored denim. Or dark indigo dye දැම්මොත් එහෙම අර මාරම dark blue jean එක හැදෙනවා. So denim materials වලදී අපි dye කරන්න use කරන indigo dye එකක්. ඒ dye එක හදන්නේ sodium metal use කරනවා. Okay? And also දැන් නම් ඇත්තටම ගොඩක් street lamps වල නැහැ, but ඉස්සර street lamps, have you seen in like old movies there are street lamps with like that yellow light? Because now most of the street lamps are like solar powered lamps. But in old movies, have you seen street lamps? Are yellow color street lamps? දැකලා තියෙනවද? මට chat box එකේ කියන්නේ එතකම ඔයගොල්ලන් පෙන්නන්න. I will also try to find a picture for you. Something like this. Something like this. Then ගොඩක් සමහර තැන්වල white color street lamps තියෙනවා, but දැනුත් තියෙනවා ගොඩක් ඇත්තටම මේ sodium street lamps. I mean, they don't look old like this. They look a little modern. But දැනුත් සමහර සමහර නෙමෙයි ගොඩක් තැන්වල තියෙනවා yellow lamp එක. Street lamps are පාර තියෙන lamp එක, right? So if it has a yellow color, that is because sodium is there. But the white color තියෙනවා වල sodium නෑ ළමයි, yeah? So this is a street lamp with sodium. This is another one. I'm just taking these pictures from Google, ළමයි, yeah? So those are the uses of sodium. Can you all write the uses alone? There are 5 uses. Okay. Up to that point, is it clear, ළමයි? Up to that point, is it clear to all of you?